I'm going to show you how you can get better at math in 1 week.
If you fix these 3 study habits, you will be wondering why you ever thought math was hard in the first place.
So here are 5 study hacks for mathematics exams.
Today, I'm going to teach you how to learn any math concept in 5 easy steps. Okay, I know what you're thinking. You've seen dozens of videos on this before, and they all say the same thing. Study hard. Learn the basics. Do exercises. Now, this is all great advice, and I'm not going to tell you that they're wrong. But many people are put off by the notion that learning math takes time, effort, and dedication. Practice, practice, practice. It sounds stressful and draining. Now, there is no magic pill that I can give you that will instantaneously transform you into a genius mathematician. But this video will teach you a method to learn any math concept. And while it will require a bit of effort, it's not gonna feel like a chore. And maybe you'll even enjoy the journey. As we walk through this 5-step method, I want to illustrate the process with some examples. One from geometry and one from algebra. These subjects are simple enough that most people will understand the concepts, but they're also complex enough that you can find some really challenging problems. Let's get started. The first step is discovering a new technique. Learning math is a process, and how can you learn something new if you can't first pinpoint what it is you're trying to learn? If you're listening to a lecture in school, reading a textbook, or watching a video, it's likely several different concepts will be introduced in a rapid-fire fashion. In this step, we want to isolate just one of these concepts and focus our attention on it for the time being. Try to succinctly identify the topic in a couple of words. If you have a textbook, the topic might appear in a definition or as a bold keyword in the text. In a lecture, your teacher will likely draw attention to the topic name as a title on a handout or by writing it atop the scribbles on the chalkboard. For our geometry topic, we'll be looking at isosceles triangles. And for our algebra topic, we'll look at prime numbers. Now that we've identified our topics, it's time for step 2. The next thing we want to do is try it out. Take the topic for a test drive. This is the step where we'll look at practice problems and examples from notes and textbooks to really get a feel for it. Try and answer 2 questions. First, what can this technique help me do? And second, what types of problems can this technique help me solve? Now, I'm not suggesting that you mindlessly work through examples at this point. Far from it. Instead, focus on the big picture. It might not be clear how to answer either of these questions when you first start your exploration, but some ideas may come to mind as you work through some problems. In our geometry example, isosceles triangles are defined as a triangle with 2 sides of equal length. One of the first examples you might see for the use of isosceles triangles is the proof that angles opposite the equal length sides are equal in measure. From this one example, you can draw the connection that isosceles triangles are useful for filling in information about missing angles in a triangle. It's also important to note in this exercise that we're using information which should already be understood, such as the SAS, or side angle side congruence. If one of the steps of this example doesn't make sense to us, that can highlight another technique we should take time to understand better before moving on. During this period of exploration, you might notice similar ideas appearing in problem solutions, such as drawing extra lines to form isosceles triangles that weren't already given. I want to pause for a minute to talk about an important concept that applies to any endeavor, which is intellectual curiosity. Intellectual curiosity can be summarized as a yearning to understand more about a particular topic.
Every person on the planet has this desire, although it can vary in degree and fluctuate depending on the topic. The best students are those whose intellectual curiosity goes into overdrive, causing them to constantly ask questions and seek answers.
It's not a necessity to have this desire if you want to succeed at math in school or your careers. But it does make the process more enjoyable. And this is a skill that many employers will look for when interviewing for jobs. Getting back to our geometry example, as you continue your exploration of a topic, you'll come across harder and harder problems.
Take this one, for example. We'll come back to this problem in just a minute, but for now, let's shift focus to algebra and prime numbers. Prime numbers have no positive integer divisors other than 1 and themselves. You'll be taught that every number has a unique prime factorization, although the proof of this fact won't be given until you take an undergraduate course in number theory or abstract algebra. This concept may seem strange at first because you've seen plenty of ways to multiply two different values to get the same number. But sure enough, you weren't looking at prime factorizations. Working through some examples, you'll quickly become proficient at decomposing numbers into their prime factors, although it would be a chore to do this for large numbers. You may learn or notice some divisibility rules along the way to help out in the process. Hand in hand with an early introduction to prime numbers will come a discussion of the least common multiple and greatest common divisor. But again, you'll see that the more you explore the topic, problems become more and more challenging. Let's take a look at the solution of this problem, and then we'll head back to the geometry problem we've been putting off. The first step is to find the least common multiple of 6, 8, and 10. There are multiple ways to do this, but the simplest is to prime factor the three numbers, and then multiply together the largest power of each prime from the factorizations. A non-rigorous explanation for why this works would be that the least common multiple must be divisible by each of the three numbers, so we must have at least the largest power of any prime as a factor, but any higher powers would be excessive. Once we have the least common multiple, this is how many days will pass before all three clubs meet again on the same day. To find the day of the week, we can divide this number by 7 and take the remainder, since 7 days passing would cycle back to Friday. With a remainder of 1, this means the next day all three clubs meet at the same time would be a Saturday. Finally, getting back to our geometry problem. We can fill in the value of angle BEC and note that triangle BEC is isosceles, so BE and BC are equal in length. This lets us fill in many more angles in the diagram, but we can't quite find enough information to solve for x. The key idea is to draw two new lines in the figure to form some new isosceles triangles. From here, we can systematically search for new isosceles triangles, fill in new angles, and mark off pairs of edges as congruent. With the help of supplementary angles and some basic arithmetic, we eventually work our way to find angle x is 30 degrees.
At this point, you're probably thinking, I've heard all this before, and you would be right. Up until now, this is the kind of stuff that your parents, teachers, and self-help books have been telling you. But this next step will be something completely new. By now, you've identified a topic, and you've done some exploring on your own. This third step is crucial to your ultimate success in learning a topic, and it may be the most difficult to accept psychologically. I want you to fail. Wait, I'm sorry, what? Yes, you heard me correctly. Now that you've spent some time exploring the topic, it's important to figure out your limits. Keep trying harder and harder problems until you find one that stumps you. And if you're thinking that there's no way you can find a hard enough problem on isosceles triangles or prime numbers that will present you with a challenge, You just haven't looked hard enough.
The internet is a wonderful resource for finding challenging problems, and you can always ask your teachers. Why is this step so important? Why not just learn the material you need to ace your quizzes and tests and be done with it? For one thing, some of the extra problems and exercises you work on while exploring a topic may end up on one of your exams, and you'll have a head start on the rest of the class. Additionally, by exploring a topic beyond the basics, you'll develop a deeper understanding of the concepts involved and learn how different topics intertwine. Algebra and geometry may seem like completely different subjects, but if you ever take a course on algebraic topology, or the more aptly named algebraic geometry, you'll find out they blend together to produce some absolutely mind-blowing results. It may not come as a surprise to learn that all of math is connected in a mysterious fashion. The deeper your understanding of any concept, the more prepared you will be to tackle new challenges.
We should spend a moment talking about how you know when you've hit your limit.
Sometimes it will be obvious. For example, if you can solve all of the easy questions in your textbook, but those marked hard or incomprehensible. Other times, you may not know if you're stuck or if you just need to put in a bit more effort.
And in this case, the breaking point is completely up to you. The more time and effort you apply to step 2, the better your understanding will be. But remember, this isn't supposed to feel like a chore. So if you ever get to a point where the challenge is no longer fun, it's time to move on.
As the final piece of this third step, keep a notebook of all the questions you couldn't solve. Organize the notebook by subject and check back with it every once in a while to see if your understanding has improved. This way, you always have a goal to work toward, and when you do solve one of the problems in the notebook, it undeniably shows that you're progressing toward a stronger understanding.
Having reached this point, the last 2 steps of this learning method will hopefully be fun and relaxing. So, you've reached your limit for understanding the topic. You've been a student for a while, and now it's time for you to become a teacher. Take what you've learned, try and summarize a key concept or idea, and then find a willing friend or family member, or even your teacher, and attempt to explain it to them.
A good listener may ask questions, and this is where your understanding will be pushed to its limits. You might have a grasp on the basics, but your test subject may ask something you never thought of. This whole question and answer process shouldn't take more than a couple minutes, and one of 2 things will happen. Either you'll do such a good job explaining the topic that you feel completely comfortable with the concepts, or you'll come up with new questions and look for answers to deepen your understanding. Win-win. If you're feeling really confident, you can try this out in less comfortable environments, such as study groups or when a teacher asks a question in class, but don't feel obligated to do so.
Remember, this is supposed to be a fun activity where you try to teach what you've learned to a friend or mentor, and there's no pressure, no consequences if you screw up. Once you finish this step, there's only one more thing for you to do. You've discovered a new topic, explored a variety of problems to enhance your understanding, found your limits, tried to teach what you've learned to someone else. Now the 5th and final step of the process is to take a break and move on.
Not only will this help your mental health since it gives your brain time to recharge, but it trains an important skill, which is finding a good work-life balance. It may be worthwhile to repeat this process again several weeks or months down the road, but for now, you've done great work and you deserve a rest. Head to the gym, spend time with friends, or just kick back and relax on the couch with a smoothie while you play your favorite game. There's more learning to be done, but it can wait till tomorrow. As promised, I'll give a couple hints about the challenging geometry and algebra problems presented earlier. Both require some pretty advanced concepts, so if you can't understand a word I'm saying, it's probably a good idea to just write these down in that notebook of yours and wait a few years until you have some more advanced courses under your belt. For the geometry problem, drawing a figure is the obvious first step. Sometimes if you draw the figure accurately enough, it may give a clue as to how you should proceed. Familiarity with the properties of chords of circles will help here. Think about the diameters of these circles. Can you find some points which form one? It may be helpful to draw some extra lines too. As for the algebra problem, this will be a tough one if you haven't at least had a first course in abstract algebra. Think about the ring Z sub n and use the Chinese remainder theorem to transform this into something easier to work with. Now think about what properties a number x must have to fulfill the problem requirement. Make sure to tune in again next week as we take a little bite out of another fascinating topic.